We have built an airplane for FPV and autonomous flight using an FX 703 foam plane, which has a 69 cm wingspan. The plane can be found for about €12 on AliExpress. With this foam, we built time ago a twin engine with brushed motors. The video is in the video cards, in the upper right corner of the screen. On this occasion, to save weight, we have used a small motor with dimensions 1806, which weighs only 16 grams. This motor provides a maximum thrust of 350 grams with a 5-inch 3-bladed propeller. Its maximum current intensity is 7.5 amps. The motor must be in a raised position so that its line of thrust passes through the center of gravity. Therefore, we had to mount on the nose a structure made of ice cream sticks and extruded polystyrene, so that the motor has the right height. The ESC is 12 amps and has a weight of 9 grams. The battery has 3 cells and 800 mAh, weighing 70 grams. The aircraft has a configuration of 4 servos, which weighs 3.7 grams. The flight controller is a 20-gram wing FC, managed by iNav. For such a small plane, it is best to use the Omnibus F4 Pro V3, as it weighs only 10 grams. A video on how to set up this controller to run with 4 servos is shown in the video cards. Nevertheless, we use the Wing FC because its voltage regulators are more reliable. In the video cards, there is another video on how to configure this controller. For the FPV system we have chosen a Nano V2 transmitter, with a maximum power of 400 mW, and a weight of 3 grams. It has a maximum range between 2 and 3 km in ideal conditions. The camera is a Pico-sized CAD DX Ant, weighing only 2 grams. If the frame is included, the weight goes up to 4 grams. The quality of this camera is bad. But we are using the FPV system as a telemetry system via OSD. Its most important function is to provide the GPS coordinates of the plane in the event of an accident. The camera and transmitter are mounted on a gantry made of flat ice cream sticks. We use a ROT-Go2 video receiver that we plugged into the mobile phone to record all the flight sessions. We record the flight sessions using the Go FPV app. The GPS module is a Batian 220, weighing 5.3 grams. To record videos with a better quality, we use a SQ12 mini camera, weighing 18 grams. Which let us to record at 30 frames per second with a resolution of 1080 lines. This camera is placed into the belly of the plane after being power on. At the end of the flight session, the camera has to be extracted and turned off. Then the images are transferred to the PC. Its image quality is bad in terms of color fidelity, so videos need further processing. To protect the camera during landings, we had to build a small landing gear using 4 mm diameter wooden sticks. The wheels of the landing gear have a 1.5 cm radius. The receiver is a Fly Sky X6B, which weighs 5 grams and have a range between 2 and 3 kilometers. We have tubed the receiver antennas in drinking straws to prevent them from wobbling during the flight. In the iNav we have set 1 second as the minimum signal loss time before the failsafe is triggered. In this way, we prevent the plane from returning home due to momentary signal losses. For the video transmitter, we have set a channel in iNav that let us to increase its power as the plane goes away. This minimizes the consumption of this device. The flight missions are entered into the controller using a mobile phone and the app SpeedyBee. The total weight of the plane is 350 grams. since the wing area is 0.0654 square meters. It has a wing loading of 5.35 kilograms per square meter. This is not a low wing loading, but not excessively big either, so the aircraft can be managed manually with no problems. We have set a value of 75% of the throttle range as cruise throttle. The plane consumes about 5 amps during horizontal flight. But this amps includes the consumption of the video transmitter and other devices. We think that the motor consumes about 4 amps at most, so it is far from its maximum intensity. Of course, in climbs and turns, consumption exceeds 7.5 amps, so we must take care not to introduce flight paths with a high unevenness, so as not to expose the motor to amperages above from its maximum for a long time. We are flying about 50 meters above the ground, with low rates of climb that require small pitch angles. In the tests that we have carried out, we have noted that the plane is flying at about 40 km per hour. In addition, we have reached a maximum range of 2 km. We have not been able to fly beyond this distance because the battery does not provide more flight autonomy. The efficiency of the airplane is 125 mAh per kilometer. This means that it can fly at most about 4 km, including the return to home flight, before the battery drops to its minimum recommended voltage level. This same electronics can be used to motorize other foams of similar dimensions, or even to motorize a little glider, that cost only €8. Although for these two cases, it is recommended to use a more powerful motor that can consume about 10 amps continuously. Now you can see some images of the flights, recorded with the mini camera placed at the belly. And this is all. Thank you.